share the screen. Enter your chat room. If you have any questions, you can put in the chatting room. So the Zoom group chat. So I will look at that and answer your question. Before I start my class, so the first thing I need to make sure is that please find your partner for the group project. At this time, since we don't do face-to-face class, so it's very headache for us to determine who will go to the project 1 and which group will go to project 2. So here I change the rule is you find your partner, and then I will assign the group project to each group. Is it sounds okay? Okay, please let me know your group members by sending me an email or through the course mail or through the email directly. That's fine. So in order to make your task easier, so I only allow 2 for each group. Okay, so you and the other guy. Since we practice the social distance, so 2 people, you can use Zoom or you use FaceTime, whatever, so that you can talk forever. So it's just like 2 people, so it will be okay. Oh, hey, now, any other question about the group project? Okay, no response, so now I can start my class. So here, today we will finish our computer architecture so that we can build our physical computer with the binary version of your machine code. So you can control this computer, you can write the machine code on this computer, and it will run based on your program. Of course, if you want to do more, like I want to do assembly, or I want to do symbolic version, I want to do assembly, I want to do high-level language, so we still have more work need to do. But this extra work will be separated into 2 courses. One is still this course, computer organization. We will do a little bit talking about the assembler, talking about the virtual machine, and then we will move to the operating systems so that it will give you more clear picture on how we organize our memory, how we do assignment on the memory, how we do process, how we deal with multiple threads. So this is more advanced topics which will be covered in the operating systems. And one more word. We have already started to register the course for the next semester. If you haven't done so, please register the course online. Okay, so a brief summary of the last class. we finish our memory from the last class. So the memory, actually, we have the ROM and the RAM. So the ROM is for the instruction. So let me see the RAM. So the RAM is quite easy. So this is the RAM. ROM 32K. So you have the address. There's no input in the ROM. This means that your program have already been stored in this ROM memory chip. And then your output will be the instruction. So this is the instruction machine code. And complicated thing is for the RAM. So the memory for the RAM. So the memory, actually, this one, you should have three parts. One is the data, which will store the new data you write into this RAM, or it will fetch the data from the memory. And another thing is you should have a memory for the screen. So that it will be the output. This is the simple output. And you should have a very simple, for the hack machine, it has a very simple input. So the input is the keyboard. Okay, here is the architecture for the memory, which is used for data and the screen and the keyboard. So you can see that this is the address in our memory. So we have 16K RAM. So make sure this one is not a 16 kilobytes, okay? So here is 16K, means it needs a 16K address. And actually the size will be 16 times 2, because why I know that this is 16 times 2 for the bytes, because the output here is 16 bits here. So if it's 16 bits here, it means that actually your one access or your one reading, this one will carry out 2 bytes, 16 bits. So 2 bytes. So you use 16K times 2 bytes for each load, then it will be 32 kilobytes. And for the screen, still remember our screen is 512 times 256. So this is our screen. So let us see. So the last time we did our screen, your refresh is the black white screen is 256 by 512. So this one, last time we do the calculation, right? Here is 2 to the power 8. This one is 2 to the power 9. So it's totally is 2 to the power 17 bits I need. So 2 to the power 17 bits I need. So for the address here, 2 to the power 17 is how many? 2 to the 7 kilobits. So divides 8. So this one is 2 to the power 14 kilobytes, 64 kilobytes, and then 2 bytes. So totally it will need 8K memory chips for the screen. So each one will be 2 bytes. So totally is 16 kilobytes there. And you can see that this one is the memory address will be from 8K memory address. And then for keyboard, so for the keyboard, it's quite easy. Each one is just 16 bits there. So you only need one address for the keyboard. So in summary, so your address bits is 15 address bits, and the input and output are all 16 bits. More than half, actually, this one is 16K is for the data, 8K for the screen, and 1 register for the keyboard. And the memory address is assigned is showing on this slide. And how do I know which part I want to access? It's based on your address. If this address is between 0 to 16,383, then it goes to the data portion. If it's between 16,384 to 24,575, it goes to the screen. If it's just 24,576, it's from the keyboard. So based on the address, I can separate those devices. And all the other address is invalid. You can see that we still have a bunch of memory address we don't use, because 2 to the power 15 covers more than 24,576. Okay, so this is the whole thing for the memory. So today, our class will go on with the next part is CPU. CPU is the calculation, right? So the CPU is the calculation. So CPU looks like a little bit crazy. We have the data from the memory. So this is a memory output, right? So we have 16-bit from the memory. So here is our from in memory. So this one is data from the memory and enter to the CPU. And we have the instruction from the ROM. This one is 16 bits. And the reset bit is just 1 bit. If you want to restart your computer, you should let the reset bits to be 1. Otherwise, it's okay. So reset. And inside built-in CPU, we have D register and A register. So these two registers are associated with CPU. So it's not with the memory, okay? So this is the register associated with CPU, D and A. Okay, so can I write something? Or let me see. Okay, so let me write something. So inside the CPU, you will have 2 registers inside the CPU. One is A register, and the other one the other one is D register. Okay, so the other one is D register. Okay, these two is associated with CPU. If you hack machine language have M equals to D plus M, so the right side you have M portion. So in here you have M portion. This data will comes from in memory, so it will be here. So through here to enter the CPU, if your right side has M, and which memory address I want to access is actually determined by the A register. It's associated with CPU. Okay, so the instruction, this portion actually is from your ROM. Okay, so this one is from your ROM. Okay, this one is from your RAM. So this is actually the data or maybe the keyboard information. Okay, you have 2 possible input. This one is from data. One is from data, or it may be from your keyboard. Okay, your keyboard. Okay, I don't want to write too much. So keyboard. Okay, so the instruction is from the ROM, and the reset is a kind of 1 bit If it's 1, it means you want to reset this CPU, means you restart your computer. Okay, let us see the output part. So the output part. So when you fetch the instruction, for example, m equals to d plus m, so you have m input here, the value is here, so you will have ALU within the CPU. So ALU to calculate, you will put d plus m, right? The value in d, for example, the value in d is 5, and the value you fetch from the RAM is 2. So you total, you 2 plus 5, finally you will get 7. So now this value, 7 value, you will look at where to go for this result. So if your left-hand side has M, this means that you want to write into the memory. So you write into the memory address is is provided by A register, and this 7 will through the out to the memory. So it will goes to the data. It can be goes to the RAM. It will go to the RAM, right? So this RAM may include 2 things. One is the data, still the data. It can be the data, or it maybe go to the screen. Okay, it will show in the screen. Okay, it will show in the screen. Okay, then you should, this one is the indicate whether you allow to write to the memory or not. So the write M is just 1 bit. Okay, then this one is the address of the M determined by A, right? You should give the A values and put into address M. So this two, out M is the data, address M is the address, which is the input to the RAM. So this two combined together, and the write M you can treat like a load bit, the load bit. So this 3 together allow you to write into the memory. And then we have already, we have in our previous we do the machine code, we have another thing is we may jump, right? So this one is the PC will say that which one you want to jump. But in this example, we don't have jump, so the PC will let the PC increase by 1. Okay, so in summary, let us in summary. So here is ALU and 3 registers. One is A register, one is D register. Definitely you need a PC register is the program counter, right? Program counter. You need to know who will be the next. So CPU has 2 circle, a logical circle. One is we called execute circle, execute logical circle, and another one is called a fetch logical circle. So let us see. So here is the execute logical circle. So CPU will execute the instruction according to the hack language specification. The D and A values, if it appear in the instruction, are read from or read to the respective CPU resident register. So D and A is associated with the CPU. So you don't need to load from the memory or write to the memory. So this one directly can do read and write. If you have the M value at the right side, is read from the in M. So it will, if you have M in this example, if you have M, so it will read from the memory. If you have the M at the right, left-hand side, so equation you have the left-hand side, then AAU will output to, in the place of out M, this is the data in the out M, and the register A will give the address M. So A will hold the address, so this one will give to the address M. And write M is asserted, so it's allowed to load to the memory. Okay, so this one is the execute logic. Okay, any questions? Okay, so now we go to the next one. Okay, so no questions, so we move forward. So we go to the next part. The next part is the fetch circle. Fetch circle is for the things for jump. Okay, so the fetch circle determine which instruction will be the next. So here in this example, we don't have the jump, right? If you have the jump, so here, so you have the jump, and this jump will determine where to go, right? So this jump will be, so let me write. So it's not related to the D register, so I will not write anything with D. So here, the fetch portion is related to A, okay? Your A register. Your A register hold the instruction, see? And then this is RAM, this goes to instruction, right? And it has a instruction. Oh no, it's not here. Should be erase this. So instruction, you have dm equals to d plus m. If I have the jump to say that, okay, jump to some place, and then it will first check the reset bit. So the first thing is ALU associated with ALU. So for example, I write one thing is D, so compare and jump, right? Okay, so in our assembly language, we say at 15, okay? So if we have this kind of code as our input, okay, at 15, D jump, no, not good. So let me see, MP, no, I will say that, okay, I will do less than. Okay, so this means that if D is smaller than 0, then I will jump to 15, right? Jump to 15. Jump to the instruction at the 15 line, at the 15th line. So what does it mean? At first, how do we do this one? So when it's fetch this code, so the first one at 15. So this one, A will say, okay, this is the 15. Okay, I get the address value is 15, the 15th line. And then D, JLT. So it will do, ALU will compare. So ALU here, it will do D smaller than 0. It will check whether D is smaller than 0 or not. So this one is ask the question, is D smaller than 0? Then it will emit two possibilities. If it's greater than or equal to 0, it will say 0. It will emit 0. Otherwise, if it's definitely smaller than 0, it will emit negative 1. Negative 1. Okay, this is a little bit tricky. So here is for the hack machine, it's designed like this. So we just follow the hack machine. So if it's no, it will emit 0. So it's 0.
it will be, if it's yes, it will emit -1. Well, if we do this way, then what else? So it will look at, so now CPU will check for the reset bit. If a reset bit is 0, it means that it will not restart this computer, okay? If it's equal to 0, it will not restart the computer. And now it will do the things is check ALU emit values. If it emits 0, if it emits 0, so it will say that PC equals to PC plus 1. So suppose my current running is at line 9, then it will be go to 10. Okay, so this one is for the ALU equals to 0. My current will do the 9th line, it moves to the 10th line. Okay. If ALU say is smaller than 0, so it's negative, means this one is true, then my PC output will be say that, okay, now you are at line 9, it will move to line 15 because it's recorded at A register. So it will jump and set the value of A. So this is PC. And else if reset bit equals to 1, then if reset equal to 1, then I will set PC to 0. So the line 0, the very beginning line. Okay. So this is the fetch logic. Any questions? Okay, good. Now we can revise our review, our C instruction. And this one is, okay, this is our table. Hey, I don't want to go over, spend too much time on this part, but make sure that we have the A value, C1, C2, C3 to C6 for the computation, D1, D2, D3 for the destination, and the jump is J1 to J3. So the destination actually is the left-hand side of your same symbolic version, and A plus C1 to C6 is the right-hand side. And then jump is the way we do, we compare with 0, and then if it's satisfied, it will jump to the certain place. If it's not, it will move forward, move to the next line. But this is jump, it will do is compare, you may get is greater than or less than or not equal, equal or whatever jump. Okay, so this one is the C instruction, but this one is not the purpose for I to remember. This one is the actual things in our CPU. So our CPU implementation. Oh, this CPU implementation, you will see that our CPU will have, let me see, so major things, ALU, this guy. You have D register, you have A register. This is the PC register. So the PC register is for the instruction. So the instruction. Now we have the in memory. So A address will do, and this one is our stuff. So the logic is here. Okay, so let me see. So each circle C represents one or more control bits taken from the instruction. So we have the control bits here. So we have the control bits. So it will related to whether you related to A register or you do the C register or D register, or you deal with the program control register. So this one is the C. So this is the command. And the instruction enter. So when you enter the instruction enter, you will do the decode. Decode is based on your binary representation, right? So you have this guy. So showing on the top. So this one. So here. So it will first look, okay, this is C restriction. This is the C instruction. And then it will do A. It will get A, C1, C2, C3, C4, C5, C6. And then through this A, I know it deal with the AD register if it's equal to 0, or A equal to 1, it will deal with the A and M, so the memory. So A will determine here. So whether you deal with AD or you will deal with AM, right? So the destination part also will D1, C1 to C6 is the calculation. So this calculation is done at the ALU. ALU will, based on the control, it will fetch the data from D, or it fetch the data, it obtain the data from A or M, right? If smaller lowercase a is 1, it will fetch the data, it will obtain the data from the A register. Otherwise, it will get the data from M memory. So this C, A will, this lowercase a will also control here. Oh, let me write down something. So small a here, this guy will control this. So here, so to make sure that which one you want to calculate, you want to obtain A or M. So C1 to C6 will do the computation. So C1 to C6 will control here for the ALU to calculation. So whether you want to plus or you want to minus or you want to just do to hold the D value. So this one will control here. And now D1 to D3, D1 to D3 is the destination, right? The destination you want to put. So the destination, you will have this guy. So you will have the output here. So go to here. So the destination will determine, no, not this guy. So the destination will say, so this is the output. So it will go to the out M or write to M, so here. So this one is, it will control here. So you want to write to the memory or not write to the memory. So it will write to here. And if it's right, then it will get the address M and out M, right? The destination will control it here. So this C will also control the D register. It will say that whether it's related to D or not related to D. It will control here. It's whether it's related to A or not related to the A. And then the destination will also, the destination will consider it here. So the D1, D2, D3. Okay, so it's a little bit mass. Okay, so C1 to C6 will control this three. Whether you will do A or you will do D register, A register, and ALU, what kind of arithmetic you want to perform. Okay, the destination part, D1 to D3, it will control this guy. It will say that whether your destination include the memory or not. It will also do this to say, okay, it will also control this one, whether your destination will include the A or not. So this will select to put into the memory A register. Or if it's not, then it will put the instruction. Okay, the final, we have the jump part. So if you have the jump, definitely you need to control this guy to say that, okay, hey, ALU, oh, hey, ALU, so this guy ALU, no. So the ALU will see that, okay, so not this, not here. So if it's a jump, it will consider the first guy is, okay, the PC guys. Okay, you should go to certain place, which is related to A. So if you have jump, it will do the PC guys. So the also ALU will emit a -1 or 0. So this guy will also control at here. Okay, so it will control at here to say that, okay, you will do the next step or you next line, or you will go to the certain place. Definitely you have the reset. The reset actually will reset the PC value to 0. So actually the PC is the register, also is the counter. Okay, so this one is the whole thing. And our circle will have the execute circle and the fetch circle. And the execute circle will do the decode. You will get this control message. This control message actually is this guy. And then you execute, you based on this information, A information, C information, D information, J information, you will execute. D information, A, C, D information, you will do the execute. Fetch one is based on the jump information, J1, J2, J3 jump information, and determine whether you go to the next one, the next line, or you will jump to certain line given in A. Okay, so the last one is the resetting circle. So if you reset, the computer will reset to 0. So the PC will equal to 0 if you reset it for the resetting. Okay, so you will equal to 0. Okay, so this is the whole CPU function. Wait, so that's good. No one have problem. So this one is looks like straightforward, right? Okay, now where's my chatting room? Okay, so and now we build together. We can build our computer. So we have memory, we have CPU, and now we can build our computer. So the computer looks like this. I have the set. Inside I have the clock. We have the ROM, we have the RAM, and we connect the output device, for example, screen, and we connect the input device, for example, the keyboard, and the whole thing is the computer. This is the chip name, is the computer, and the input reset. So you will probably will see the next homework by the end of this week to ask you to build the computer or to do the assembly. Okay, so this one is the computer. So the whole function is looks like this. If reset equal to 0, will the program stored in the computer's RAM executes. If it's set to 1, then you will restart the computer. And okay, so this one is a CPU on chip. Hey, no, now we look at, okay, this is the whole picture of your hack machine. So we have CPU in the middle. We have the data memory. We have the instruction memory. So instruction memory is just to give you the instruction. So this one is the RAM, 32K. And the data memory will do is hold the data as well as communicate with the screen, with the keyboard. So this is the whole thing is right into the, and the CPU is the whole do the calculation. So what's missing in CPU is ALU, D register, and A register within associated with the CPU. Or the memory is at the data memory, and the instruction will be stored in the instruction memory. Okay, so we have finished our computer. That's all for today's class. And starting from the next class, we will do the software part. So hardware part, we have already done everything finished. So starting from the next class, we will do the software part of our computer. So the beginning one we will do is, so in your midterm, everyone has already create assembly language and then convert a symbolic version and convert to the binary version. So the next one we will do is assembler. Okay, so this one, assembler, will be the first software used to translate your assembly language to the physical language, to the machine code, so the binary version. So this one, we will do it automatically, not like your midterm you write and translate by yourself. So we will use, through the assembler, we can do it automatically. Okay, any question? So for the next homework, it will maybe need 1 or 2 weeks because your next homework will not only include the computer, but also include the assembler. So it will be 2 weeks. So, but I will post earlier so that you can look at this homework. Okay, so that's all for today's class, and